नमस्कार दोस्तों, मैं अभिजीत और आप देख रहे हैं एबी स्टडी सर्कल। वीडियो में आगे बढ़ने से पहले अगर अभी तक आपने इस चैनल को सब्सक्राइब नहीं किया है तो इस चैनल को जरूर सब्सक्राइब कर लें और बेल आइकन को भी जरूर दबा दें, क्योंकि जब भी नया कोई वीडियो आएगा आपको नोटिफिकेशन मिल जाएगा। Let's dive in. In this video, we are discussing about a problem that is associated with the concept of available energy, and this question has been asked from the CSVTU University examination in 2008. The problem says that a system at 500 Kelvin receives 7200 kilojoule per minute of heat from a source at 1000 Kelvin. The temperature of the atmosphere is 300 Kelvin. Assuming that the temperature of the system and surrounding remains constant during the heat transfer, find out first the entropy produced during heat transfer. Okay. Second, the decrease in available energy after heat transfer. For the first part, it wants us to calculate the entropy produced during heat transfer. That means when there is a heat transfer between source and system, that means how much it wants to find out the net entropy between the source and system. Okay, so we will find out the entropy for the system and for the source, and we will have the algebraic sum to find out the net entropy change due to this heat transfer. Okay, so for that, let's first find out the entropy change for the source. Okay, for the source. Okay, it is d cut q by T. T is the source temperature. Okay, source temperature. It will be, as it is rejecting heat, that will be minus 7200. As it is in minute, I will be converting into second, right? Okay, and the temperature is 1000, so it will be minus 120 by 1000. So the final answer would be minus 0.12 kilowatt per Kelvin. Okay, so now let's find out the entropy change for the system. The system, it is receiving the same amount of heat that is being rejected from the source, so it will be positive. So I am writing 120 by the system temperature is 500 Kelvin, so it will be 0.24 kilowatt per Kelvin. This kilowatt, because it is in kilojoule per minute, we have converted into second by dividing it by 60, and it will be kilojoule per second, that is kilowatt. Okay, so ultimately the algebraic sum of these two would give us what? The net entropy that is produced due to this heat transfer. Okay, so ds net is nothing but ds source plus ds system. Okay, so it will be minus 0.12 plus 0.24, that is 0.12 kilowatt per Kelvin, and this is the answer for your first part of the question. Okay, so let's remove this whole thing, as we have got the first part done. So we will be going for the second part of the question. Okay, the second part of the question is related to the decrease in available energy, and for this decrease in available energy, as it is the heat is transferred from a finite temperature difference, this is basically belongs to the concept of loss in available energy or decrease in available energy due to finite temperature difference, and this particular concept we have discussed it in detail in our previous video, which you can watch by clicking in the I button. Okay, so let's draw the TS diagram for this whole diagram. Okay, so we have this S, writing is okay, so we have this temperatures, okay, and we have this surrounding temperature with us, that is T0. It is T0, the system which is operating between T1 dash, I am writing T1 dash, that is 500 Kelvin, and T0, that is the atmosphere, that is at 300 Kelvin, and the source temperature from which the system is receiving that 7200 kilojoule per minute of heat is at T1, that is 1000 Kelvin, and it is taking Q1 amount of heat. The system is taking Q1 amount of heat, which is rejected by the source, which is taken from the source, and the system, after doing work, so after doing work, it will reject heat to the atmosphere, and due to which we will have a ds dash, that is the entropy change due to this whole system, and this part is the loss or decrease in the available energy, because if the system, if it is directly transferred from this T1 to T0, then it would have an entropy ds, and but as it has transferred the heat to the system from this source, and the system is operating between T1 dash and T0, the entropy is ds dash, and for this the decrease in available energy is T0 ds dash minus ds, where this ds dash is nothing but Q1 by T1 dash minus Q1 by T1 for this ds. Okay, so after simplifying this, you will get T1 minus T1 dash by T1 into T1 dash. Okay, so this is your decrease in available energy, right? Decrease in available energy, and let's find out the final value by putting the values here, right? So we have T0 as 300, decrease in available energy, right? So 300 into Q1 is it is 7200 by 60, that is 120, right? And it is T1 is how much? T1 is 1000, T1 dash is 500, and it is 1000, and it is 500, and the final value will be getting as 36 kilowatt by calculating this, and this is your answer for the second part. And I will suggest you to view my previous video, which is on the concept in the decrease in available energy due to finite temperature difference, to have a clear picture of how we have got this whole thing up.
right? Because this is the main formula which will be used to calculate the decrease in available energy. If you find this video useful, please like this video, share with your friends, and if you have any doubt, please comment in the comment section. Thank you.